Hello, geeks. I am Aman Soni, and I welcome you all to the GeekSpeak. Today, we'll be having a healthy discussion over the Transformers. Of course, not that movie. We'll talk about the Transformers, the building block of GE&I. But wait, what is Gen I? Well, I'm Gen I.
Okay, so hello everyone. This is Aman Soni, and what you have seen just right now is just a glimpse of what we are going to cover in today's video, right? So let me begin with myself. I am Aman Soni. I just joined a month before, and what we are going to cover in today's video is about the transformers, and we are going to take a look at what transformers are and how they are used, and how do we even get there to build a transformers, right? So before diving right into the transformers, I want you to tell me about the names of the applications that you have used recently that involved AI. For example, let me give you an example. First, we have the Chat GPT and the Gemini, which we are using extensively for the development purpose and every other thing that we are like seeing today. Whether it is content creation, whether it is preparing the slides for the presentation, right? I haven't prepared from that. Okay, so other than that, there is Daily and there is Mid Journey. Daily is for like the image creation and the runway, and also we have the Siri and the like Google Assistant, right? So let me just write them down here. Okay, so these are the basically used AI applications that we are using right now, right? So let us first classify them on the basis of what they actually are, right? Okay, so we have Gemini and ChatGPT. That is a chat-based AI, right? Then after that, there comes the Daily and Mid Journey that can create image from the text, right? Then there comes the video and text part, and then there comes the most loved one, Siri and Google Assistant for the speech and text, right? So there is one thing that is common here, and that is this text keyword. Like if we have to do anything with the AI right now in this generative AI era as well, we need to deal with the text, right? So text is the big keyword here. So let us first have a discussion over the text only. So yeah, here it is. Before that, we used to do the vector encoding in like every language that we are using right now, right? So we know that our computer doesn't understand the words that we are trying to use as an input. It only understands the numbers and it's like the bits and bytes, right? So for that, what we used to do was we used to take the ASCII values of every character that we are taking as an input into it, and according to that, the computer is getting to know itself. Like, okay, this is A character and this is B character. But in case like if we have the large data set, we have a huge amount of text data. There we can't use that ASCII value feature, right? Because like we don't have that kind of storage space, right? So for that, instead of using a character as an token, we are using the words as a vector. For example, instead of giving a ASCII value up to a particular character, we are providing the ASCII values, or you can say the vector, to the particular words, right? So if we are like, for example, let's take example of the king won the match, right? So in here, what we can do is we have certain values that are associated to a particular vector. For example, we have fruit, we have tech, we have royalty, we have sports, and we have pride. And I want to like represent my word king as a vector here, right? So what I'll do here is I'll create a vector in which I have multiple values. For example, fruit tech, and royalty, what we have seen right now. And as we are seeing, king here have a value that is associated to royalty to a much extent, right? So that's why we can see here the royalty is of 0.96% and the pride is of 0.82%. And also the fruit value that we are getting from this king keyword is 0.05, right? So that means it is representing the word as a token instead of accepting the ASCII values, right? So we have covered it. Okay. So let's take the entire paragraph as our input, and the process that we have just covered till now was called the word embedding. right? So we have covered the entire paragraph as an input, and we are getting some bunch of vectors as an output, right? That is totally fine. That is working perfectly fine. But what if, let's suppose we have two sentences here. One is Apple is healthy, and another one is Apple is a new product here. So here, if we use this static approach of the word embeddings, what we are going to have is, let's suppose I prompt GPT that I want to eat an apple, right? And then after that, I'll give another command. Now I want to buy an iPhone, or which is from Apple, or like I have to buy an Samsung phone. GPT will be confused, right? Because we have used a vector in which the fruit value is high for a particular keyword, that is Apple here, right? So for that, we know this isn't gonna work, because we have fruit, we have tech, and both of them are having the same word embedding. So how are we supposed to use it? It's a problem, right? So for that, what we did was, we know we had to do something like, whenever we pass a keyword, we need to have the keywords from the left side of it and the right side of it. Basically, we need to have a whole sentence. We have to understand the context in which it is used. Then only we can do the embeddings, right? So for that, that was a static approach. I have written beside, like below every slide, that it is a static approach. Okay, so to deal with this static approach, we need to have a dynamic approach, right? So that was a static embedding. And now we have to find a hypothesis or a function that can take the static vectors as an input and give us the vectors as an output that are not static, that are dynamic, right? So that is called the self-attention. Self-attention doesn't mean like a big keyword here, okay? So self-attention just means we are taking static embeddings and getting the dynamic embeddings out of it, right? So how do we do that? Main purpose is this, right? So let's suppose we have a keyword apple here in a sentence of Apple is healthy, right? And now, instead of like passing directly that to a model, what we do is we find the similarity of that apple keyword on the every word that we have in that sentence, right? So we are like writing apple here in terms of every keyword that we are having in that sentence. Apple is written in the form of apple is and healthy, right? And there is one thing you will notice here. Okay, we can write that. There is no problem. Every word is a vector here. No problem. But how are we supposed to find out the similarity? How are we supposed to find out like what is the percentage of like healthy keyword in the healthy, right? What is the percentage of apple in that healthy, right? So we need to have that similarity. Now I want you to remember the class 11th, right? So for similarity, what we used to do is, basically there are two vectors, right? We used to plot it on a graph, let's suppose two-dimensional graph. And from that, we used to find out the similarity between their angles and their values, right? So we will use the same approach here. What we will do is, we'll take the vector healthy, we'll take another keyword that is apple, we'll take another keyword that is, and we'll take another keyword as a healthy. And then after that, we'll take a dot product of those two vectors, right? So if we are taking a dot product of a vector which is in the form of 1 cross 5 and 5 cross 1, of course we are going to get a scalar value, right? So that scalar is the similarity between these two vectors, right? So till now we have seen like we are able to like embed the vectors, right? And in the form that it can change over the time with the help of like corresponding sentences, right? So in this case, if we are having two sentences, one is apple is healthy and another one is apple is having a new product here. Okay, so apple is healthy is having another vector associated to it, and apple in this another sentence is having the another vector in it, right? So we have solved this problem, right? So now we have seen how to input text in a model. But wait, what is model? We were here to talk about the transformers, right? So let's go to the transformers. But before that, let's choose long-term, short-term memory as a model here, right? In 1997, it was showcased in a research paper by the Kepler University. So what it used to do is it used to take the input, and it has two threads. First one was the long-term memory, and another one was the short-term memory, right? So let's use that. Okay, we have used that, and we have we are seeing the results. It will work absolutely fine if the number of input in this model is equal to the number of output we are getting from this model, right? For example, let's take a example of a machine translation. For example, we have a line that is over the line, okay, and we have to get a translation in the Hindi for that line, okay. Then we are having rekha ke upar as an output, which is perfectly fine. That means the model is working perfectly fine. But what if we are having different number of inputs, I mean different length of input, and the length of output is different? For example, the weather is good. We have 4 words here, right? Then we are getting the output, which is of 3 words. Mausam acha hai, right? So this was the disadvantage of long-term, short-term memory. So that's why we have to refuse it, and we have to find another model so that we can train our model, right? So then in 2014, here comes the paper by sequence to sequence learning by the neural networks. That was nothing but an encoder decoder architecture, right? So we have solved that problem that we were facing previously, the number of words are varying, right? So this architecture properly perfectly did that, right? Okay. So what was the problem here? I want to exercise. I have exercise for you. I have this paragraph for you, right? So I want you to read the stuff that is highlighted here and translate it to me after reading the entire paragraph. I think everyone must have read it till now. Can anyone translate that entire paragraph to me without even seeing to the paragraph? No one can, right? Just because once we are passing the entire sentence, till we pass the last line of that sentence, we are forgetting the first line. So how are we supposed to translate that line by line, right? Even we are facing this issue. So the same issue was faced by the encoder decoder architecture. It used to work perfectly fine on the small sentences, but in case of large sentences, or if we are talking about the current scenario, we are passing up loads of data into it. It won't be able to translate, right? So that's where Google research team dropped a bomb that is called the Attention is All You Need research paper. And that was the beginning of this AI era. Believe me, before that, AI was a thing, and now it is a huge thing. We all know that, right? So what it did was it took all the input embeddings and created an n-dimensional space. Okay. And the idea was to map every word to the point in a space where the similar words and the meanings are physically closer to each other. That means the guitar, violin, and all these kind of stuff are presented in a same space on the two n-dimensional space, right? Then after that, taking the entire sentence into it as an input, then did the positional encoding, what we have just seen till now, the tokenization. Then we are having this dense layer in which we are training the model. And then after that, we are getting our results, right? So this is perfectly fine. This is our transformer architecture, and it is doing wonders, right? What was the main advantage of this model is all our previously described models was sequential models. That means you have to pass entire sequence, and then after completing that sequence, after completing that training, the next line will be passed into it, right? So that is not something we need. Like we have the loads of data and we have to train our model. So for that, instead of using all those architectures, if we are using the transformer architecture, it is a parallel approach, and it will like take every what do you say every sentence as a different thread, and it will pass into it, right? So we were able to pass that very easily. We were able to pass that, and we were able to train that in no time. So the transformer model opened the gate for the entire generative AI, right? So we have seen like we have covered the like whole timeline. We have seen the mathematics behind that. So let us code it now. So let's start from the TensorFlow library itself. Let's install the TensorFlow, and yeah, I have used my Python notebook in order, Jupyter notebook in order to run my Python commands. Okay, so we have installed the TensorFlow. Then after that, we have imported the pipeline from the transformers. Pipeline is nothing but it's a flow of data, like in which direction the data is flowing from what layer, right? So from transformers, we are importing pipeline, and then after that, in the pipeline, we are using a pre-built model, that is the sentimental analysis by the Hugging Face, right? So we are creating an object of classifier here, and we are initializing it with a pipeline and a sentiment analysis model, right? Perfect. Then after that, we are passing a line classifier. We are happy to show you the transformer library. Okay, we are that is something we are passing as an input, right? Then after that, we are getting a result of positive. We can select the number of labels as we want. Like we can select either we want from the range of 0 to 5, or like some other words, right? Happy, sad, or anything like that. So in this case, we have only labeled two things, which is positive and another one is negative, right? So the score is 99.98. That totally means it is 99% sure that this sentence we are using is having a positive impact on the product, right? So let's take an example. Let's take an example like we are having elections in our community, and everyone is posting on the social media. Everyone is posting on Twitter. Everyone is posting on the Instagram. And now you have to find out what percentage of votes are aligned towards you. What percentage of votes are aligned towards that particular party in a positive way or in a negative way, right? So we will scrap the data. We'll take the entire data as an input in that classifier, and we'll get the label according to every tweet, and then we can classify, okay, so this party is winning and this one is not winning, right? This is a normal example. And not only that, there are multiple models that are available. So instead of that sentimental analysis model, we'll take the text generation model here from the GPT-2, right? It's an open source model, and we are passing a single sentence which is not completed. That is, in this course, I'll teach you how to. Then after that, I have left it, right? So what is going to be the next sentence that will cover that up? There are two sentences because I have returned two number of sequences to the two. It will give you two sentences. First one, in this course, I'll teach you how to build a personal computer to build and install some of your software. And another one is, in this course, I'll teach you how to get the hang of the project, right? So this was this another model from the transformers only. And we have a bunch of models. We have for text classification, text generation, summarization, image classification, segmentation, object detection, and all of them are open source. We can use it from like Hugging Face library. And for those who don't like to code or like want to use from a particular kind of GUI, we have another approach to that. We have a low code approach as well. So this is auto train website by the Hugging Face only to create the powerful AI model without code. Okay, so after we have clicked on the create new project, we'll get this page. Okay, and from here you can select your base model. Like I have selected GPT-2, and then after that I can pass my training data. For example, if I have to pass like I have an examination of the CA tomorrow, right? And it is an open book exam. Okay, so I won't like do that, but still, okay, it's an open book exam. But then after that, I am passing the entire book as a training data into my GPT-2 model. Okay, and it will learn from that. Then after that, in examination, I don't have to like flip the entire pages of the book. I just have to write the question, and it will give me the answer in the format that the book is having, right? Not recommended, but still. Okay, so this is the low code approach. And not only that, we have a bunch of options available. I remember one time I did that. Like I have created a 3D model with the help of a single image that was in a 2D, right? From 2D image, I was able to create a 3D image, and that is fabulously awesome, right? So these are the kind of models that are easily available for you to use. So just explore that, guys. Okay, thank you.